Good afternoon, guys. Welcome to my YouTube channel. My name is Hasan Zeki Alp. I've been presenting you modern programming languages in my YouTube channel. Channel name Hasan Zeki Alp, user Hasan Zeki Alp. And this afternoon I will be presenting you a next lesson for Dart programming language in English. At the same time, I've been presenting these courses in my native language in Turkish. And by the way, content will be the same, and I'll be using the same development environment just for the sake of being universal, being known in globally. Just I preferred to make this video in English. That's all. And right away, I'd like to start up our development environment. Just I said, I use ECLIPSE IDE environment. Beforehand, I have prepared some code snippets in order to present you, just to save time. Because I'm not good at typing quickly, and mostly I do typing errors. Anyway, okay, just we have seen 11 files, Dart files, and this is file 12. And in this file, I'd like to present you operators, arithmetic operators. Just as you can remember, as you can recall calculus lessons, operators can be plus sign, minus sign, and multiplication sign, and division sign, and what else? Division without remaining, or other saying, returning integer, division returning integer, and modulo arithmetic operator, or remainder function as a result of division, and increment operator, and decrement operator. Do not regard being double, just it increases just one. That means if it is assigned as 2, it's gonna be 3 instead of 4. Okay, let me show you such examples. I here define two variables such as num first and num second, and as they are assigned as 101 and 2, and I here define another variable so as to be called as result, res. So it's initialized as 0. I here just simply make an addition operation here, and this is the addition operators. And this is the operand first, and this is the operand second, and the result will be assigned as the summation of these two variables. And just I'd like to get it printed by means of this structure by calling this print method. Addition equals to, and I use here dollar sign since it's a numerical value. However, it's gonna be printed within a quotation mark, in fact. So in this example, just I repeat my simple arithmetic operation, subtraction operation, and here once again I assign the result as res, and I use the same structure, same format, dollar sign, curly bracket, and open curly bracket and close curly bracket, and numeric value will remain inside. And this is the multiplication, as you see, and this is the division. Okay, each time I repeat my result variable. For example, here I say result 2, and in order not to cause any inconveniences, and this time this is very new for Dart users, in fact, because it's not called such a thing. Just that reminds me negation sign. However, here is used together with this combination tilde and slash, and that means division returning integer. So if the result is 5.1, the result will be just 5. and this is the remainder function or modulo function. If it is 5.1, 1 is the remaining one, that's to say. Okay, this is the increment value, and this is the decrement value. How was our value? 1.101. So res number 1 will be 102, and number 2 will be simply 1. I would like to make it run and show you. Okay, addition, subtraction, multiplication, division, returning integer. Okay, simply integer part, only integer part, and remainder, and increment value, incremented value, and decremented value is displayed on the screen. Okay, I'd like to show you another example. Okay, here equality and relational operators. Okay, if we say equality, we're talking about double equal sign, because only if we use only one equal sign, it's gonna be interpreted as assignment operator, and in order to make a distinction between this and that, and I have to use this equal sign, double equal sign, and what else, being greater than the other one, being less than the other one, being greater or equal to the other one, being less than and equal to the other one, and this is the negation. Okay, that can be translated such as if number 1 does not equal to number 2, that means let me say as a result of this expression, in fact, will be true, because in fact this one and that one does not equal to each other. So as a result, this expression gives a true result, and this is gonna give a false result. And here I would like to mention one thing. In fact, the result of this comparison, this relational comparison, will give a logical result, in fact, such as true or false. So it's gonna make some cause, it's gonna make inconveniences, because we are going to make it right in a string format. So I simply use to turn it to string type. This is the method, you guys. This is the logical result. So by mentioning logical result dot and invoking this method, it is so easy to translate this logical result in order to be a string result, so as to easily get printed. And this is repeated for the other ones as well, as you can see. Yes, and that's to say, that's all. And let me run and see the result of this code snippet. Okay, lots of text, and false, true, and does not equal to, okay, true, as I said before. Just in fact, it's not equal to each other. However, thanks to this not equal to sign, it's gonna cause to give a result of true, and this is false. And let me show you another example. Okay, type test operators, that's gonna be presented you. Okay, I'd like to take your attention here. The effect region of this main method is starting from here, this curly bracket, and ends this curly bracket. That means all these commands will be performed by the compiler or interpreter, sorry. And at first I want to assign one variable n, so as to be integer as 2, and I simply make a logical comparison, sorry, not logical, test type comparison. N is integer, just as if I ask in English, n is integer, Sure, and is integer. The result of this expression, this type operator expression, is true, and it's called is operator. You guys, is operator is. Instead of using a double equal sign, for example, just we can use is and is integer, and it's gonna get printed so as to be true. True. That means, okay, yes, and is integer. And how about the next one? Okay, here we go on with our type test operators. This is not operator. The opposite of is operator, in fact, as a functional manner. So I define a variable n so as to be double and includes 2.20, and var num is gonna be assigned as a result of this comparison, type test comparison, and is not integer. Okay, of course this is true, because in fact n isn't integer because it's double. So the value that's gonna be assigned for a number variable will be true again, once again. True. Okay, let me show you another example. That's going to be the final for this lesson. Okay, this is bitwise operators example. Bitwise means we can consider the number in binary level. That's to say, bitwise means that is. And let me define a variable var a so as to be 2, and its binary representation is like this: 1 2. That stands for the digit 0, and then this is digit 2. 2 times 1 equals to 2, in fact. And how about the other variable b so as to be 3, and its binary presentation or bit presentation will be like this: 1 1. So 1 stands for 1 for unite digit, and this stands for the multiple of 2's digit. However, this is the only one. That's to say, as a result, 2 plus 1 will give a result of 3, and this is corresponding to this variable in value, in binary value. Okay, this is the prelude for this comparison, and for binary comparison, bitwise comparison, we have to use this single ampersand and a single vertical sign. Okay, as you remember, double ampersand or double and sign stands for logical and double vertical line stands for logical or, in logical level or. And this is a bitwise operators example. So let me focus on this. Var result will be assigned as a result of a and b in bitwise level. So just look here. A and B, 1 and 1 will give 1, 2, 0, 1, 0 and 1 will give 0. So the result will be 1, 0, the same as A, okay. And let me get it printed so as to display the result. Okay, how about this one? Okay, let's go step by step. Okay. Just as I said before, A and B, that's going to be translated as 1 and 1 will give 1, 0, 0 and 1 will give 0, 1, 0, it's the same as the value of A, in fact, okay, here, just as you can see. How about this one? This is the representation for or logical expression. And here A or B, let me translate it is like this. 1 or 1 will give a result of 1. 0 or 1 will give a result of 1. So the result will be 1, 1. So it's the same as 3. So it's going to be 3. How about this one? This is the representation of exclusive OR, you guys. Exclusive OR means that instead of giving OR and ordinary OR results, both the operands will be considered. If they are both 1 or 0, the result will give a result of 0. So we exclusively select the single comparison, singular comparison, in fact. And as a result of this singular comparison, I mean as a result of A exclusive or B will give a result of 1. And how about this one? This is the negation, or okay, just this is negation. However, this is a negative value of this one. Okay, just consider this 3 and consider its a binary value. Okay, 1 1. If we consider about negation, all bits will be transverse the opposite of that bit, corresponding bit. So so simply it corresponds to minus 4. Minus 4. Where are we? Okay, and this corresponding to shift left operation. In fact, A will be shifted to the left side, and how many times will be shifted, and B will give that result. That means the result of A in binary manner will be shifted B times to left. Okay. As a hint, just I can say that in binary operation, if we shift any value, any number to the left, that's going to be multiplied by 2. And if we use numeric value, for example, decimal value, and this is going to be 3, for example, in decimal manner, and A will be shifted B times, will mean that A will be multiplied 3 times by 2. That's going to give a result of 8, in fact. And here just we're talking about this one. However, just let me repeat this one. 2 times 2, this is the first multiplication, times 2 times 2, that means 2 to the power of 4, in fact. So it's going to give a 16 value. Okay, just as you can see here. And how about this right shift? Right shift means that all the bits, all the most significant bits will be shifted rightmost side, and it is translated as a division, in fact. However, in this case, all the most significant bits will be vanished and will be lost, and it's gonna give a result of 0, in fact, because 3 times we shift it to the right. Let me show you. We shift it to the right, and we make it blank for the shifted digits with 0, and the result will be 0, in fact. Okay. Yes, guys, by this English version, we have completed the third lesson of Dart programming language, and as far as I have enough time, I will be going on this English version lessons. Thanks for your for sharing time with me, and I hope you will get the most benefit of these video courses. And thanks again. I wish you a happy weekend, happy afternoon. Bye bye.